Hello, everybody. My name is Daniel Cormier. I teach the 310 and 320 sections of the object-oriented course in computer programming. I was invited to show this to you in person. Unfortunately, because of scheduling conflicts, I'm unable to do so. I hope you'll find this video a reasonable replacement. What I want to tell you about is this little extra side project that I've written for my classes. I'm inviting you to participate as well. In this, and I'll show you how it operates shortly, I will be giving you an interface class. You will write code that, using that interface class, will create a tank. That tank will, using your code, drive around in this battlefield, find the other tank, and shoot it. That's your job. The wrinkle here is that the other tank is also written by another programmer, and it will have the same goals as yours. This is competitive coding. Let me show you how it looks. I've got a few sample tanks that were made. I'm going to put a sort of okay tank on the left. I mean very sort of okay. And the basic example tank I've given you on the right. I'll start things off. Now, the example tank is actually quite bad. I'm not going to make any bones about it. All it does... Oh, let's get rid of that. Mostly what it does is it generally goes forward and every now and again turns. And if it has a clear line of sight, it'll shoot the other guy. The Skeletor tank was some attempts at getting an AI to write this code, and it's really more complicated than an AI can easily manage. Now then, how this is going is every time the move is called, your tank will burn 1 liter of fuel. If you run out of fuel, you lose. And you have 4 moves. You may go forward, you may turn on the spot, clockwise or anti-clockwise, or you may fire your gun. If you are staying in the same square for more than 1 turn, you get up to 3 turns actually. After 3 turns of being stationary, your tank will start to burn a whole lot more fuel. It's an intentional penalty. It's designed to encourage aggression. There's only 100 liters, 100 turns, and this battlefield is 32 squares across from green square to green square. So it's going to take a bit of time to get out there. And you'll have to be aggressive if you want to not suffer the indignity of running out of fuel again, as the red tank is about to do. I'll speed it up a little bit. There's a few more wrinkles to it. You probably saw very briefly the red tank had a square that appeared. So briefly, the blue square had line of sight. I'm using a simple ray casting. So if the tank is facing in the right direction and there are no intervening objects, then the other tank is visible. This is critical because if you can see the target, you will gain information on where the target is and its heading, and we'll make use of that. Let me show you what all that means. We'll start with the interface. This is the interface you're given. It has some constants for your convenience. These are your tank orders. Forward, clockwise, counterclockwise, fire. So you can just return counterclockwise. That's all you need to do. These are your 4 directions, so you can use those for your convenience as well. I'll return you an integer, 0, 1, 2, 3, and they mean these. Basically, you can work out this sort of clockwise. So right is clockwise of up. This is the actual battlefield. Now, I think in terms of X and Y coordinates, not rows and columns. So this is literally the same map that you saw here. The difference is it's sort of rotated a little bit. That's all. But you can see here's where this is the sort of little hockey goal type blocks are, etc. You can see them here, right? This is just 90 degrees off. These are the 2 important methods. You have to code these. Initialize is going to be called when your tank is first created every combat. So every time a tank is blown up, a new combat is started. And it's simply telling you where your tank is, the X coordinate and Y coordinate, and which direction it's facing. The rest of it is up to you. You can use it for whatever initializations you want. Every time you want to move, rather every time it's a time for your tank to move, my engine calls update on your tank. Tells you which direction you're facing, here, your X and Y coordinates, whether you see the enemy tank or not, and if you do, these variables are populated. So I will tell you where the tank is and which way it's going, and you can use that information to figure out where you want to go or what you might want to do. It's entirely up in the air. The other three are simply getters. Have them return some useful information. Whatever you put in tank name is what other people are going to see and how I will present your tank. And that is also what shows up in the combo boxes. The reason there were a bunch of Skeletor tanks is my buddy who wrote a couple sample tanks for this he's into Skeletor for some reason. Doesn't matter. Make it a cool name. Just no profanity, if you please. Lastly, where does that leave us? I've got some information to explain some of the how to actually set this up. I made it as straightforward as possible. And some of the mechanics behind the combat itself. There's a couple wrinkles you should be aware of. They're discussed in those files. I'm going to give you a sample tank as well, which I'll step you through in a moment. And the last thing I wanted to show you is once you've written your tank, simply put the .class file here in the same directory and edit this tank list and simply put your name in it. So you can put whatever you want. But it should be the name of your class file. The code won't quite work right if you put something else. So you see there's a dantank.class. There's an example 2. Where is it? .class, right? So you can use Eclipse to write your code. Find the .class file and put it in. All right. Lastly, where does that leave us? The sample tank. Here. All right. This is a very, very basic tank, just to show you how things go. So my initialization doesn't really do anything. I simply take the parameters I'm fed and I've stuffed them into variables. Doesn't even do anything of value, honestly, because I promptly erase that when I call update. You can see it here. My tank, this example tank, checks to see if it has line of sight. So visparam. If it doesn't, it has a no line of sight method it calls. Otherwise, what this is doing is checking to see if it has a clean shot on the target. And if so, and it is within range. And if so, orders a shot. That's it. If it's out of range, it moves forward to close the range. If it can't see the target, this is code to make it bumble around. Basically, 90% of the time it goes forward. 10% of the time it's going to rotate one way or the other. It's really, frankly, it's quite useless. But it shows you how it all comes together, I hope. Once you have your tank completed, kindly send it to me. My email address is cormied@algonquincollege.com. We'll make sure to post it online in your course section so you can do that. The due date will be the end of December, so you've got a couple of weeks after the exam. This is just for fun, so don't sweat it, right? Just have some fun with it. When I have enough entries, probably in the new year, I will put together a little elimination bracket and post it on this YouTube channel. And I'll let everybody know what the URLs are for it. I wish you all the best, and I hope you have some fun with it. I'm looking forward to seeing your entries. Take care.